Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about Parity Generator. So in the field of digital electronics, it is very important to ensure the data integrity. For this purpose, we have two digital circuits, namely Parity Generator and Parity Checker. So both these circuits help us to detect and correct any kind of error in the transmitted data. So before going into what is parity generator, we need to know what is parity bit. In digital signal processing, an additional bit, either 0 or 1, is added to the original binary or digital code to detect and correct any kind of errors in the data that can occur during transmission. This additional bit is called as a parity bit. So the addition of parity bit to the original digital code makes the total number of ones in the code either even or odd. Thus, on the basis of number ones in the data, the parity can be classified into two types, namely even parity and odd parity. If we add a 0 or a 1 to the original binary code and this makes the total number of ones in the code an even number, then it is called as even parity. On the other hand, if we add a parity bit, that is 0 or 1, to the original binary code and this makes the total number of ones in the code an odd number, then it is called as odd parity. So, the parity bit is one of the simplest forms of error detection technique used in digital electronics. Next, we'll see how does the parity bit work. Suppose we have a code 0101. So, this code has total number of ones as even and because it has two ones. So, in the case of even parity, we add a parity bit 0 to the original code to make the number of ones an even number in the code. Therefore, after adding even parity, we get 01010. So here 0, which is the parity bit, is added to the end of the original code. In case if we add uh, a 1 at the end of the original code, then we perform odd parity. So we'll be getting 01011. Now the total number of ones in the code, including the parity bit, is odd, that is 3 ones. So this ensures the odd parity scheme. Next one, we'll see what is a parity generator. A combinational logic circuit that can generate the parity bit according to the original digital code is known as a parity bit generator or a parity generator. The parity generator is used at the transmitter end and generate an odd or even parity bit, and we add a parity bit to the original code before transmission. First, a parity generator reads the input data and then it calculates the parity bit accordingly. Once the parity bit is generated, it is added to the original data code. So this gives an output code which is the original code which is newly generated parity bit. So there are two types of parity generators, even and odd parity generators. So first we'll see about the even parity generator. A even parity generator is a type of parity generator in which the parity bit, which is either a 0 or a 1, is added to the original data so that the final digital code contains an even number of ones, including the parity bit. Therefore, we can state that total number of ones in the output of an even parity generator, including the parity bit, is even. So in the case of an even parity generator, if the digital code contains an odd number of ones, then the even parity generator will generate a 1 as parity bit to maintain the even parity. If the digital code already contains an even number of ones, then the even parity generator will generate a 0 as the parity bit to maintain the even parity. So this is the truth table for even parity generator. So when we consider the first one 0, 0, 0, 0, so we will be having we are having no ones. So when we put a 1 here in the parity bit P, it will become an odd number of 1. Since we are designing a even parity generator, we need to add only a 0 here. When we consider the second case 0, 0, 0, 1, the number of ones is odd here. So when we add a parity bit as 1 here, we'll be getting two ones and it will become an even parity. So will be output of the even parity generator will be 1 in this case. So like that for each and every code we will be uh, finding out the even parity bit. And when we draw the Karnaugh map and simplify the output for even parity, we'll be getting A XOR with B XOR with C XOR with D. So we'll be getting the circuit as shown here for the parity bit P, which is A XOR with B XOR with C XOR with D, and along with the parity bit, all the inputs A, B, C, and D will be transmitted to the receiver as shown in the diagram. So next we'll see what is odd parity generator. So it is a type of generator that adds a parity bit to the binary code so that the total number of ones in the output code is an odd number. So it is called as an odd parity generator. So if the original data contains an even number of ones, then the odd parity generator adds a 1 as parity bit to the original code to maintain the odd parity. If the original data already contains an odd number of ones, then it will be adding a parity bit as 0 to maintain the odd parity. So this is the truth table for odd parity. So it will be the reverse of your even parity. So the output of odd parity is the reverse of the even parity. So as shown here. So including the odd parity bit, you should be having odd number of ones here. So the expression for this will be A XOR with B XOR with C XOR with D the whole bar. So like the even parity here, you will be getting A XOR with B XOR with C XOR with D, and you will be including a NOT gate at the end of the circuit, so in order to create the bar function. So similar to the even parity here also, along with the parity bit P, all the 4 inputs will be transmitted to the receiver as shown in the diagram. Hope you understood how the parity bit is generated both in even and odd parity. Let us take up some assessment questions. So the BCD number 101011 has dash parity. The options are even, odd, both even and odd, and undefined. So here when we count the number of ones, we are having 4 number of ones. So it is even parity. What is a parity bit? The options are an error detection is achieved by adding an extra bit. After addition, the carry is found. Bit generated during data transmission. After addition, the total number of bits. So the answer is an error detection is achieved by adding an extra bit. Thank you for watching this video.